do a formal verification to make sure that it is correct. So we use trace equal theory and we draw traces for the cases we just mentioned our approach. So we use field module to do the traces. And these are the traces we have drawn to the our approach and the payment job manual. And like this, we have compared the two approaches. And this is the payment job manual. This is our approach. So there's the additional part is there because it's a proposal sign function which is not mentioned in the pages line. But for the actual content, we need to do the proposal sign content. So when comparing, we only consider these two parts because this is an additional part which is of the smart contracts. And then for the trace equal, we use to verify that these traces are equal. We use contracts in just standard and contracts in assembly language use the model trace and we traces are compared using the trace equal. And this is the formal verification of trace equal and from that show that these contracts are equal. And then the conclusion, we have shown that we have achieved the optimization from the transformation tools already assembly, and we have showed that these are formally correct, that they are semantically correct from Peyton Jones language and the our approach. And then for the future works, in our case, we have taken the optimization in terms of cost, but we doesn't take in terms of speed. Because there are so many contracts being traded in the financial market, so the speed is also something a crucial concept. So it's something that we can use in future to do. And then in optimization, we only considered about the code generation and the handcrafting from the code. That's what we have. We did consider about the optimization from the abstract syntax tree. So in future, as a future work, optimization in terms of IST also can be done. And that's it for this. And thank you very much for listening and have a good day.
Thank you, Sahani, for the presentation and your work. So I open the floor for like any questions for Sahani. Sahani, so you said your future work will involve comparing speed improvements as well. So how do you plan to do it? Like, you have any ideas to do it? Yeah. And we can't really hear you. Like.
Hello. Now can you hear?
Yeah. Now we can hear you.
In the blockchain, there are limits where we can go with the speed, but in the file has to do.
Can you repeat it again, please? We could really hear.
Okay. With the blockchain, there are limitations up to the limit that we can go.
Okay.
So we have considered that, but with the financial market, sometimes for the milliseconds, there are lots of transactions being traded. And for that, we need furthermore researchers to work on that.
Okay. So are you continuing your work? Or?
Yes, I'm planning to continue that.
Okay, Sahani. So I thank you again for your work and for the wonderful presentation. Thank you. So yeah. So we'll move to the next paper in our session. That's titled Transforming Monolithic Systems to Microservices, an Analysis Toolkit for Legacy Code Evaluation, done by Shamika Bandara and Indika Pereira, both from Department of Computer Science and Engineering, University of Moratuwa. So our presenter today is Dr. Indika Pereira. He's a senior lecturer attached to Department of Computer Science and Engineering, University of Moratuwa, Sri Lanka. His research interests are software engineering, user experience, technology enhanced learning, and immersive environments. So I had the pleasure of working with Dr. Hindika in lots of areas. So it's a pleasure to welcome him here. Welcome his presentation to be presented at this session. Over to Dr. Hindika.
Thank you, Dr. Malik. My presentation is recorded. Please share it. Thank you.
Hi. In my presentation, I'm going to talk about transforming monolithic system to microservices and tool analysis toolkit for legacy code evaluation. My supervisor is Dr. Indika Pereira. I'm Chairman Kasum Bandara. So before moving to my research, I would like to give you a brief introduction about the monolithic systems and the microservices architecture. So in monolithic systems are basically multi-tier architecture, most of them, and mainly most of the all the code is maintained within the same code base. They deploy as a single unit, layers are dependent, run under single process contents. Many companies have invested years to build these enterprises application with monolithic approach. This monolithic architecture has its own benefits as well as drawbacks, but lesser benefits, higher drawbacks. And when it comes to benefits, it's simple to develop, simple to test, and simple to deploy. So when it comes to drawback, there are quite a lot. So it's complicated to understand how to make changes for fast delivery, especially if you're a new developer. So getting familiar with new code base is quite hard as it's very complex and large. And since it is one code base, as it grows gradually, every programmer, whether it's a UI developer, business developer, layer developer, comes in the same code base, which become very inefficient to manage. And scaling maybe can be very cumbersome. And also if you're using the IDE, so it eats a lot of memory from your machine to load such a huge code base. But when it comes to microservices, so some of you may know, some of you may not. Microservices are the one that uh, uh, lets you develop system using single isolated services. These services will have their own code base, their own database, and these services can be developed independently by different teams and using different technologies. When it comes to the benefits, there are quite a lot because each microservice is small and focused on a specific feature and business requirement. These can be developed independently by a small team of developers. This reduce deployment time, testing time, and code complexity, and new team member onboarding time. All sort of these. If it's easy to scale because of these small and one single function focused nature. It's loosely coupled and it allows easy and flexible way to integrate automatic deployment with configuration, integration tools, and all sort of these things. And also at the same time, with these benefits comes with drawbacks. Since it contains such a system contains a lot of microservices, due to distributed nature, deployment testing can be complicated and tedious. And also at the same time, we have to mitigate fault tolerance, network latency, and also we have to deal with the right of message format as well as load balancing. So when the number of services increases, integration, managing whole products can be complicated. Need to put additional effort to implement a mechanism communication between these services. So it seems like microservices are the next big thing in the today's world of software development, but there's a problem. So many companies want to convert their existing monolithic system into microservices because of the added advantages and benefits of because of these benefits of microservices. So, but there are a lot of problems. Why? Because billions of millions lines of codes in such a code base, many design related documents you have to read if you are converting those systems into microservices. Some design document may be obsolete, some design may not, document may not be found. So lack of context knowledge, some team members might already have left the organization who has already know the entire system. Those problems will come when you try to migrate those services, those systems into microservices based architecture. But what if we have a some sort of way or mechanism tool where it gives you some hint or some suggestions of possible microservices that you can extract from the existing all this system? Isn't that a good idea? Yes, of course, it's a good idea. It saves time, it saves your job, and all sort of benefits will give you. So this is the main motivation of my research. So what I'm trying to do is trying to find a way to identify the microservices lies within the existing multi-system uh, in automatic approach. So my scope of this project is narrow down ubiquitous time limitation into a one particular single architecture and the one single programming language Java based microservice MVC architecture. So for this research, I had to read a lot of research paper. In my literature review, I would like to summarize some of the migration techniques in the context. There are four major migration techniques in the context of system migration: replacement, integration, redevelopment, and migration. So in my research, what I'm going to talk about is a migration. Migration is the process where we gradually migrating some of the portion of our system into microservices based architecture while still using some of the legacy components. So replacement is something like we entirely replace the system with the host system, commercially off-the-shelf systems, and integration is something like where we develop interface to interact with the existing legacy system, and redevelopment is we rewrite the entire product from the scratch. So by looking at the cost and the technical value, so migration is the best option for us uh, in this method. So I had to read a lot of research paper by gathering almost all the information. I created this table. This table shows the current practices on legacy system migration. So almost all the systems migrations have different phases. Like as I summarize, first we need to understand the system and legacy system, then we need to understand target system, and we have to do a migration feasibility, and we need to identify the candidate services, then we have to do implementation, maybe slicing, code extraction, wrapping, refactoring, etc. And finally we have to do the deployment and provisioning. So in our method, we simplified these phases into three process stages. First is to analyze the monolithic code base. Then we have to do the service identification. Then we present the result to the user. That is where we have our system in place. Before moving to our method, I would like to give you a brief definition of microservices. I extracted this from the research paper Brown, A. Johnson, and S. So it says microservices is a costly and loosely coupled discoverable entity that interact with application and other services through often asynchronous and message-based communication model. So coarse grain mean implement more than one functionality and operate large sets. Loosely coupled mean refers to self-sufficiency services as where context to state information or use other function is not required from other services. Discoverable mean can be found on design time and runtime. So by looking at these characteristics, coarse grain, discoverable, loosely coupled, composable can be measurable, while message-based asynchronous cannot be measured in a code base. So coarse grain means functionality, discoverable means usage, loosely coupled means self-containment, composable means composability. So for the service identification, we have to use these characteristics, and we have to create a fitness function using these characteristics where it enable us to determine the mm, uh, exact match for microservices. Um, so functionality is coupling and cohesion measurement. Composability is a cohesion measurement. Self-containment is external coupling. Usage is inheritance and composition. So then once we have this fitness function, we have to consider each of the Java classes as individual microservices. Then we have to apply this fitness function each of these classes, and we have to do a clustering process. So in order to cluster these microservices, we have to leverage hierarchical aggregative clustering algorithm with the defined fitness with aforementioned fitness function with quality attributes. So for that, based on the fitness function value obtained at each iteration of the clustering process, next cluster will form using the single linkage strategy. As a final result, we have a set of clusters which has close value for the fitness function. And cutting point will be predefined height of the cluster hierarchy, which is a very easiest way to implement this functionality with the given minimum of time. There are a lot of other ways to do it, but we choose to do that way since we don't have much time. So now I would like to show you our tool architecture and implementation. This is the basic architecture. We have front end, back end, and from the front end we can upload the code base. Then we extract the file, and we do the service clustering with the fitness function, and we generate the microservices list and present it to the front end. So talking about the fitness function, as I mentioned, contains the characteristics of the services, functionality, composability, self-containment, and usage. So this alphabet usage and function is a linear combination of the identified microservices characteristics. This is I found in this particular research paper that I mentioned here. So it explains why this has to be a linear function as well. So these alpha, beta, gamma value are the coefficient weights for each characteristic that are determined by a software architecture, as well as n will be calculated as a sigma of all these alpha, beta, gamma, delta value. And I'm not going to talk about much of these details about these measurements. So these measurement functions are I listed down in each of these external research papers. So we calculate functionality, composability, self-containment, usage in the code by using these different functions. So we in our algorithm we have implemented these separate measurement functions in order to calculate their values. So once we have this fitness function, what next we do is service clustering. For each of these cluster, we apply this fitness function. Then we merge the two process cluster based on fitness function value. So we repeat this process up until we reach to the defined graph. So this is our project front end and back end, where we are in the front end, it allows us to upload file and shows the final result, and in the backend code where all the magic happens, where we analyze the monolithic code and we do clustering and all sort of this hard work. For the evaluation, we create a test project. This project contains app control, student control, lecture department, registration, payment control, likewise. So this basically a project of a university. And for the first test, we choose alpha, beta, gamma, delta as values as 1, 2, 3, 4. And based on the cluster height of 3, we were able to obtain this result. And we went to the iteration 2 with this alpha, beta, gamma values. So by using these values, we obtain this process result. And in the iteration 3, we obtain the alpha, beta, gamma, delta values as follows. So it gives us this result, final result, and with our tool. So in order to validate our result, we use two approaches. One is manual approach and the other one is automated approach. In the manual approach, what we did was, as we know the implementation for the different functionalities, we find out matching microservices manually. In the automated approach, what we did was we added sufficient logs for each of these services and function controllers. So based on these usages, we measure the how they are interact, how they are self-contained to each other. In the manual approach, as I described, so we manually cluster the services like that, and we identify manual services like payments, registration, exam department, and student and lecture service as one service. In the automated approach, we collected different logs, and based on the logs, we calculated how much each of these services interact with each other to fulfill this functionality. For example, adding a student, adding a lecture, adding a different departments. Those likewise, we gathered different information for different functionality, and we were able to identify payment service as a separate service, exam service as a separate service, department service and registration service as one service, and student service and lecture service as one service. So as a summary, both manual and approaches suggested that student lecture services should be merged as one service. Manual approach suggests all others should be independent microservices, while automated approach should merge the department as services. By looking at the code base, it's clear that department registration should be separated from the tool. Iteration 3 has given the most accurate result. That is because we have given more weight to the composability as self-containment. That is, to become a microservice, it should be able to independently develop and deploy. So as the conclusion for this research, by trying to fuse the weighted values against the quality attribute function and composability self-contained usage, it has proven that the most applicable value to identify microservices are the self-containment and the composability. So further to about result, it's had proven to consider when designing microservice, it should be able to independently deploy values. A couple have minimal dependency on the other services, have high cohesion, cost, related functionality, should stay together in the same service, have high self-containment. And in the future, we should be able to use machine learning and other related artificial intelligence techniques to determine alpha beta values, optimal antivirus for different architectures and languages. And we can design for more design patterns and more languages. Thank you.
Okay, I thank Charmika for that interesting presentation, Dr. Indika as well. So are there any questions from the audience, please, for Charmika and Dr. Indika? Okay, so that's an interesting work, really. So
thank you.
So I think, okay, you give recommendations as to what can be considered to be transformed, right?
I didn't get Malik, please.
No, I mean, you give recommendations as to what should be transformed into microservices.
Yeah, actually, this is the first part of a research which is ongoing because the biggest problem is when you transform the identifying values, even to take machine learning approach. So this one, we created a tool to capture data on transforming monolithic to microservices. So the data that we identify can be later used for training machine learning models to help with fully automation.
Okay. And high risk activities are what, like what do you define as high risk activities?
It's from an architectural point of view, like now there are certain matrices that we have to keep, like reducing coupling, increasing cohesion type of things, and especially like when you make certain migration decisions, sometimes the classes get bigger, methods get overweighted. So these are like high risks to the existing system, because we are dealing with working and nicely working systems. We don't want to break them. So that's a kind of a risk factor that we have to always minimize.
Okay. And Dr. Indika, yes, so how straightforward is it to go to other languages?
This is technical approach. Actually, we borrowed the equations and the models from previous work, and we implemented this. So apart from language construction point of view, the rest is pretty much easy to convert it to another language. It's
Okay.
very modular architecture. We can easily extend it to another language.
Okay, good. We thank the presenters again for their work and for presenting it for this session. So thank you. Thank you
Thank you.
very much, Ratika. Thank you,
Thank you.
Chamika, as well. Thank you. Okay, let's move to our third and the final paper for this session. That's paper number 51. It's titled Drowsiness Detection and Alert System for Motorcyclist Safety. It's done by 5 authors, Sagar Sumutipala, Dhanodya Veerasinghe, Melisha Jayakodi, Sashika Eranda, and Tanuja Gunasekara. All of them are from Faculty of Information Technology from University of Morato, Sri Lanka. And our presenter today is Dhanodya Veerasinghe, is a graduate of the Faculty of Information Technology, University of Morato, Sri Lanka. He graduated in 2020, and okay, so let's move to Dhanodya.
Hello. My presentation is recorded and you can share it now. Hi everyone. Our paper title is Drowsiness Detection and Alert System for Motorcyclist Safety. So the authors are Sagar Sumatipala, Dhanodya Veerasinghe, Melisha Jayakodi, Sashika Eranda, and Tanuja Gunasekara. So this is the overview of what I'm going to talk about. So I'll give an introduction first and then the related work. And discuss about the aim and objectives and the methodology, then the evaluation and conclusion, the further work. So basically the drowsiness is being in a state between sleeping and being awake. So in day by day, the number of accidents are increasing because of this drowsiness. And studies shows that the Asian countries like Sri Lanka, 78% of motorbikers are 78% use motorbikes as their daily transportation. So we mainly focus this research area on motorbike riders, and from this proposed system, it will help reducing road accidents caused by drowsy drivers. So basically the problem is because of the tight schedule in people's day-to-day life, people feel tired almost all the day. So they work very hard by the day, and they used to work late night, and they have to ride at the night time. So the possibility of happening road accidents because of the drowsiness is very high. So we thought of needing a system to identify drowsiness beforehand and alert the rider would be better. So the aim of this research is to improve motorbikers' safety by analyzing and identifying drowsy drivers using a hybrid model combining multimodal, which are the brain waves, heart rate variability, and electromyography, and alert the driver. And it has 4 main objectives. The first one is detect and analyze EEG signals to check whether the rider is drowsy, and detect and analyze ECG and EMG signals for the driver's safety, and finally the hybrid model for multimodal drowsiness detection using EEG, ECG, and EMG. For the related work, we found that for EEG signal analysis, we found that there are researchers for using 19 electrodes for data acquisition and use theta and alpha band powers for the detection. And there was a model with pipe linking to increase efficiency of EEG identification. And the gap is that it is not possible to use 19 electrodes placed in the rider's head it would be very difficult to ride him with all those sensors attached to him. So that was a gap we found. And for detecting drowsiness using EMG signal analysis, there were systems to detect fatigue using EMG correlation by electrodes placed on affecting muscle groups, and mutual information-based method is investigated for the ordinal pattern analysis of the human hand movements, including grasp and manipulation. But for the drowsiness detection, EMG signal usage is very low in this research area. And for the drowsiness detection using ECG signals, there were researchers done for using RNR, which is the peak-to-peak analysis, and HRV analysis, which is the heart rate and variability analysis, LFHF ratio by signal processing and decision making according to the slope of the graph. So also for the hybrid models, there were hybrid models using ECG, EOG, and video-based signals to detect drowsiness, and they have used 5 machine learning models. And there was a new approach to estimate vigilance level by using EEG and EMG signals during transition from wakefulness to sleep. But there were no researches done using 3 modalities, and it is very hard to analyze, get EOG or video data for motorbike riders because they wear a helmet, and it is very difficult to play those cameras and sensors in the motorbike or the helmet. So our approach is we used EMG signals, EEG signals, ECG, and by combining them we design a hybrid model. So basically our outputs as follows. For the motorist state detection, which is the drowsiness detection, we used 3 states, which are awake, moderate, and drowsy state. Awake state is the rider is completely conscious and able to drive for long hours. The moderate state is that some signs of sleepiness occur, but no effect to keep awake. And the drowsy state is that subject needs to actively try not to sleep. The driving would be very dangerous. For driver's safety, we get the output as riders, whether the rider is conscious or not, and the rider's hand muscle condition, whether the pressure on the muscle is normal or high. So this is the top level architecture of our proposed system. First, we acquire data from EEG, EMG, and ECG data from sensors, and then the pre-processing part has been done, and pre-processed data would be used separately to detect drowsiness and the driver's safety using these machine learning techniques. And finally, all the pre-processed data will be used in the hybrid model to detect and predict the drowsiness. So the methodology is basically divided into 4 main categories, which are EMG module, ECG module, EEG module, and the hybrid module. So in the EMG module, we use EMG signals for evaluate and record the electrical activity produced by skeletal muscles. We get these EMG data from the driver's forearm muscle. Inside the forearm muscles, there's a unit called motor unit, and it is made up of a single nerve cell or neuron that supply a group of skeletal muscles. The neuron receives the signal from the brain, and it simulates all the muscle fibers in that particular motor unit. Each individual muscle contains all 3 types of motor unit. This provides each muscle with the ability to produce an increased force output from low level to high level, and we get EMG signals by placing electrodes close to muscle groups. We get the voltage difference when releasing and forcing the hand. So first, we monitored the voltage difference using an oscilloscope, but the signal quality was very low, and it was very hard to measure the drowsiness state or the private state, hand muscle signal state. And then we use a myoware sensor to get the EMG signals, and it gave a quality signal compared to the oscilloscope result. So this is the signal we received from the myoware, and we get a data set by pressuring the hand on different levels. Pressure on the hand in 4 levels, like when released, low and high levels, when the muscle is fed for low and high levels. Then we used 3 classifiers to train the model, which are the linear regression, SVM, the random forest. By comparing the classification reports, accuracy and mean squared error, SVM classifier gave the highest accuracy. So for detection of the rider's hand muscle state, so SVM classifier is the better option. In the EEG module, since we are mainly focusing on building a low-cost drowsiness detection system, we have used NeuroSky Mindwave headset to record the brain waves of the driver. There are 2 dry electrodes in this sensor, so driver can easily wear without any disturbance for driving. One electrode is positioned at the ear as a ground electrode, and other one is positioned in the forehead, FP1 position. Because the electrode is positioned in the FP1 position, driver can wear easily over the hair, and hair would not be affected to the connectivity of the electrode. Brain waves mainly consist of alpha, beta, theta, gamma, and delta spectrums. First, we recorded raw EEG data, and we have used ThinkGear library and MATLAB for record data. Raw EEG data was filtered and pre-processed and used to train the model. Fast Fourier transformation was used to process the signal, and relative band powers were calculated. Relative band powers are relative delta, relative theta, relative alpha, relative beta, and relative alpha to relative beta ratio. And when analyzing EEG data, relative alpha band power increases when moves from awake state to drowsy state. And for relative beta band power also, it shows relative band power of drowsy state is higher than awake state. And here we have trained a random forest model with 30 estimators and SVM model with a linear kernel using these 5 features. And SVM model, the random forest model gave the highest accuracy as the 87% of accuracy for the evaluation. And in the ECG module, we are trying to get heart rate variability of the driver and analyze it to check whether we can use it to detect whether the drowsy is drowsy or not, rider is drowsy or not. For that, we use many sensors before, and first we used the groove air clip sensor, and it gave a digital signal as output. But we had to move for a more accurate sensor using which can get continuous data rather than digital values, because the drowsiness or the consciousness of the rider depends on the time. So we moved to a pulse sensor. Using pulse sensor and a node MCU with the help of MQTT server, we could get real-time data, pulse data of the driver and save it to CSV. The next step was to detect peaks. For that, we used a rolling mean, which we used to adjust within the same plot as the heart rate data is plotted. And all the data points above rolling mean are considered as interested window, like this. So the max value in each window is the peak. The red spotted ones are the peaks we detected. To detect heart rate variability, we had to calculate time difference between peaks. Then we plotted the heart rate variability against time. Then the Fourier transform of the heart rate variability and get low frequency and high frequency values and get the LF to HF ratio is the next step. According to biomedical researchers, LF and HF associated with conscious and unconscious activities of brain. So the brain activities, unconsciousness gets increased according to the brain activity, and LF to HF ratio has to be decreased. So this is monitored according to the time, and we plotted the line. So this is the rule-based technique, and asking from 20 to 30 people, the accuracy was determined, and the total system truth as consciousness, and compared the total ground truth as consciousness, and for unconsciousness also. And evaluation for consciousness is the system truth over the ground truth. This is how the ECG module was evaluated. And for the hybrid model, we acquired data from EEG, which is the neuroscribe, ECG data from pulse sensor, and EMG signal from the myoware by connecting to a same person, and pre-processed data for the 10-second intervals, and then scale those data and train the model for the prediction and detection of drowsiness. So first, recorded data for the 3 states, which are the awake, moderate, and drowsy states for 5-minute time periods and periods using those sensors, and removed outliers from ECG and EMG data, and split those data into 10-second windows, and for the feature extraction, calculated mean, median, and standard deviation of each 10-second window for ECG and EMG data. And for feature selection, used an AMN model to train using ECG and EMG data separately along with EEG features. So the median values from ECG and EMG gave highest accuracy, and so the selected features are EEG, from EEG, relative delta band power, relative alpha, relative theta, and relative beta band powers were used, and from ECG, median values of the pre-processed R2R intervals were taken, and from EMG, median values of voltage differences were taken. Then this is a further analysis for the relationship between features. Principal component analysis was done, and this is the correlation matrix. And from the right column, you can see how these features are correlated with the class, and also the density plots were plotted for each features. And you can see that the blue line, which is for the drowsy state, has a slight horizontal difference, which is a gap, compared to a big and drowsy state. So for the models in this hybrid model, we used ANN, SVM, KNN, and LSTM model for forecasting. So hyperparameters tuning for ANN is done as follows. Use two hidden layers, and configured as this, and out layer activation function as softmax, and use loss function as categorical cross entropy and the atom optimizer. And to avoid overfitting, used dropouts between layers in the model and used early stopping. This is the output graph with early stopping and without early stopping. And for the SVM classifier, the hyperparameters are tuned as first we used a polynomial kernel, polynomial RBF, sigmoid and linear kernel. Then found the best optimizer using grid search method, and fine-tuned estimator is used kernel as the RBF and gamma value as 0.001. Also, the learning curves for two kernels, which are the RBF kernel and the linear kernel, was plotted with tenfold cross validation as tenfold cross validation. So you can see that RBF kernel has a more accurate version. And for the KNN, found that the optimal number of neighbors 3 using k-fold cross validation by plotting them against cross validation accuracy and misclassification error. So for the tuning hyperparameters for better performance of LSTM when forecasting, we used input layer shape as the number of steps and the number of features, then stacked LSTM layers, LSTM1 and LSTM2 configured as follows, and used a dense layer between. Then the output layer used activation function as softmax, and when compiling used categorical cross entropy as loss function and the atom as the optimizer. For this also we used avoid overfitting, used dropouts between layers, and used kernel regularizing here also, and early stopping. This is the graph against epochs and the loss with early stopping and without early stopping. Finally, for near real-time analysis, integrated the system. First, we acquire EEG, ECG, and EMG data for every 10 seconds. Then, once all three types of data are acquired, those data were fed to the hybrid model. So, in ANN model, it gave 96% of accuracy. For SVM, 95%. And for KNN, it gave 96% of accuracy. For the forecasting model, which is the LSTM model, it gave 94% of accuracy. So comparing them for the evaluation, the sequence model is preferable to detect motoric state more accurately because drowsiness vary with the time. So it would be preferred to get a sequential model. So using ANN and LSTM models are perfect for this choice. Final detection and the prediction was done like this. For every 10 seconds, the rider's current state was analyzed, detected using the ANN model, and the predicted using the LSTM model. So as for the conclusion, we can see that we compared the accuracies when using one modality alone and when getting them all together. For drowsiness detection, we use the EMG and the hybrid model, EEG and the hybrid model. So from EEG module, the random forest gave 87% of accuracy and SVM gave 86% of accuracy. Then in the hybrid model, when combining EEG, ECG and EMG signal data all together, ANN gave 96% of accuracy and SVM gave 95% of accuracy. So comparing this, we can see that using three modalities together is more effective than using each modality alone to detect drowsiness. And we can use a LSTM model with 95% accuracy to forecast the motorist state in each 10 seconds. Because of the environmental and resource constraints, detecting drowsiness using ECG and EMG signals became a hard task. So detected motorist consciousness using ECG and hand muscle conditioning using EMG signals. For the further work, this project can be extended to develop a smart helmet, including these modules to then analyze the motorist drowsiness level and alert him, as well as his behavior, and help him to navigate then the helmet can be also used to predict some diseases that may found in the rider's body. So that's all. Thank you.
Okay, I thank Dhanodya and the team for that interesting work and for that interesting presentation as well. Dhanodya, I have a okay. I mean I let the audience raise any questions for Dhanodya, please. Okay, Dhanodya, I have a question. Like, okay, so it's a nice piece of work. So did your evaluation involve real motorcyclists as well?
No, actually, because of the environmental and resource constraints, we used students. Actually, we gave them video, like a video game, which includes motorbike riding and simulate the environment.
Okay. Okay, so like in your finance system, like when you finish your project, will the motorcyclist be totally different with all those sensors on him, or like will it be very intrusive for the motorcyclist? I hope not, right?
Sorry, I didn't get the question.
No, I mean my question is, will your system be like uncomfortable for the motorcyclist, like to put all those sensors on the head and so on?
No, we think to develop it as to get the EEG data. We can attach the sensor in the helmet.
Okay.
And for the EMG data, we can include it in the jacket.
Okay, good. And it may be like a straightforward thing to like move it to other drivers as well, right? Not only motorcyclists, right?
Yeah.
Okay. And also, you like want to alert the rider as well, so it will be like in the form of a bell or something, right? I don't know, like.
Yeah. Or we can use a alert system in his phone, like that.
Okay. Okay, so thank you very much for the interesting work. Like we wish you the very best for the continuation of that work, which will be very helpful. Because I myself have felt sleepy when I was driving on the highway, like in the afternoon. So this will be a very helpful thing. Thank you again for the presentation and for joining this session. Thank you.
Thank you.
Okay, so let's move to our papers. So our first, I think the posters. So the first post is post number 58. It's titled Wearable Walking Robot Module for Children with Disabilities. It's done by 4 researchers from the Department of Electrical and Telecommunication Engineering, Faculty of Engineering from Southeastern University of Sri Lanka. The researchers are HMS Pabasara, ADD Fernando, RBLN Sandaruan, and PMK Alhakon, and also WGC W. Kumar from the Department of Computer Science and Engineering, Faculty of Engineering, Southeastern University of Sri Lanka. So our presenter this afternoon is HMS Pabasara. He has the BSc Honours in Electrical and in Electronics Engineering. He's an application support engineer at IPD Colombo. So over to Pabasara, please.
I'm Samde Pabasara from Southeastern University of Sri Lanka. I'm here to give you an introduction about our research project, Wearable Walking Robot Model for children with disabilities. Children who have undergone brain injuries, spinal cord injuries, and neurological diseases such as cerebral palsy can't walk or move on their own, so they need someone else's help in their daily routine. Cerebral palsy is a common disorder that can be found among children, which leads to shortening muscles and deformed bones. So these patients need regular therapies to get better. Physical therapy is human intensive and should have the support of skilled person or therapist. So rehabilitation exoskeleton robots have become very popular nowadays in treating people who have these difficulties. So we have built this exoskeleton robot to provide therapy for children who have walking disabilities. This robot consists of 2 robot legs. Each leg has 2 rotating joints at hip and knee with 2 degrees of freedom for each leg. And also there's a walker to hold the body weight of the patient, and we have built an Android app to control the robot. The robot system is mainly aimed at the use of rehabilitation of children between 5 to 10 years old. So the weight limit is up to 35 kilograms. The exoskeleton can navigate through 2 parts actually. One is linear and the other is circular. So the path can be selected using the mobile app. And the main control board consists of 2 microchips that are connected to the Wi-Fi module. Each microchip is connected to two drivers to drive the NEMA 17 stepper motors. And the width and the height of the leg can be adjusted according to the patient, and robot legs are mounted to patient's legs using adjustable belts. So the robot is connected to the mobile app using ESP32 Wi-Fi module, and it will establish the connection between mobile app and the robot using cloud database. This mobile app is used to it can use to walk robot in a test mode, and also using the app user can select path, count the number of steps, walking distance, and also can access to previous activities and the future goals as well. There's an emergency button set on the walker, so that when there's an emergency, the user can push the button and stop working the exoskeleton, disconnecting the power coming from the battery. And also there's a camera mounted on the walker through which the parent can monitor the child. We have redesigned the walking pattern according to the patient's capability, so only one joint rotate at a time. So you see here the rebuilt walking pattern, and as the final output of the robot, the angle variation of the joint has been measured and plotted against the gait cycle. So you can see we have achieved the redesigned gait pattern after building the robot. So we have to test the robot with real-time data and check the efficiency of the robot. So that is pretty much all about our project, wearable walking robot model for children with disabilities. And thank you for listening.
Thank you, Professor, for that interesting presentation, and also like a very useful robot for children. So how does, okay, so I'll first let questions be asked from the audience, please.
Hello, I'm Janaka. Actually, I wanted to know that have you thought of like holding the children in your robot? Like, did you design a special mechanism, or how did you thought it?
To hold the child, there's a walker. So with that walker, there are belts are attached, and so that walker will hold the body weight of the child. So it will. We
So
have
did you thank you. Did you think of a particular disability or
Yes,
when design?
this is mainly due to cerebral palsy. That is
Ah,
a walking disability. So
ah,
they can't move their legs properly. So it is specially for them.
okay. Thanks.
Okay.
Any more questions for Abusara? Okay, Professor. So thank you very much for that, for your, and thank you for you and your team for that work and for the presentation as well. And also, how does your like work stand at the moment? Like, has it been presented at exhibitions, or like where does it stand now?
It's with the faculty right now, and we are trying to develop it for further. I mean, this is up to 35 kilograms, so our aim is to develop it for the purpose of you adults as well.
Okay. Okay, so thank you again for coming and presenting your work at this session. So thank you, Professor, and your team.
Thank you.
Okay, so our last post for this session is poster titled 142. It's titled An Enhanced Learn Evaluation Method Based on Psychophysiological Signals. It's done by Isru Nanayakara, Dr. Hiran Ekanayaka, and PHPI Madhuranga, all from UCSC. Presenter this for this session is Madhuranga. He has a BSc Honors Degree in Computer Science from UCSC. He is currently an assistant lecturer at UCSC. His research interests include psychophysiology, cognitive science, machine learning, EEG, Internet of Things, and robotics. Over to Madhuranga, please.
Hi, I'm Mr. Nanaka, and our research is an enhanced learning evaluation method based on psychophysiological signal. First, let's have comparison with the traditional evaluation method. So basically, in the traditional method, we have learning phase, then we design some questions, then learners write some answers for those questions, then we evaluate those answers, then we get some results. So in the proposed method, we say it has same as to the learning phase, then we graphically design the questions, then we display those questions to our learners. Then while they are watching those questions, we simply capture those brain waves and analyze those brain waves. Then we generate the results. So let's move to the graphical design in the question phase. So basically, it will look like this. In traditional method, if you want to evaluate the Pythagorean theorem, so basically we ask them to write the formula. In the proposed method, we simply show this picture: a squared plus b squared equals c squared. So in the traditional method, if you want to evaluate the mass energy equivalence, we ask them to write. In the proposed method, we simply show this picture. So let's move on to this display those questions phase. So basically, we display those pictures to our learners. So basically, we develop our evaluation method based on the Bloom's taxonomy. I'll give some examples. So if you see something object like this, so basically there is some activation going on our brain, then we identify this as a water bottle. So it's the basic level of the Bloom's taxonomy, memory level. So it will same as this Albert Einstein picture. So we identify this as the person of this picture. So it's the remembering level. So if we see something like this, so there is several applications on our brain, and other than we identifying this is Isaac Newton, so we know that this picture have to something to do with the law of gravitation. So other than the remembering level, we have understanding level. Basically, in the traditional method, so these activations are expressed as some answers. So it will be a written one or oral one. So in the proposed method, we simply directly capture these activations as brain waves. So in the traditional method, we evaluate those expressed answers, but in the proposed method, we analyze the direct brain waves. So we generate our results based on these brain waves. So in the traditional, if we have a comparison like this, in the traditional method, we evaluate the some evidence that are expressed by the learner. So if someone has some inability to express himself correctly, so we we uh, we can't actually evaluate that person correctly. In a proposed method, we directly evaluate the psychophysiological signals like brain waves, so we can directly evaluate the learner. Like so, so the proposed method, we analyze this brain waves and predict whether the learner already knew a particular content or not. In this research, we only analyze the objective one and objective due to hardware limitation. Objective one mean factual remembering of factual knowledge, and objective mean understanding of conceptual knowledge. So objective one, we use human faces. This is we have two classes, known and unknown. So this for objective two, we use mathematical equation. So we use emotive epoch plus device for EEG capturing and as a transmitting device, and to capture the EEG data, we use this ECI electrode cap. So in non-mathematical equation, if we analyze on the ERP skull maps, we find that for the alpha frequency there is no much difference, but in the beta frequency there is a higher amplitude level and higher activation for the when we see in the non-mathematical equation, and we find that the alpha frequencies it's same for the known and unknown, but in the beta frequency we find that for in unknown human faces the higher positive activations are going on the human brain. Then we use the LSTM approach, since this EEG data time series and LSTM nodes are capable of identifying the time series pattern. So we use Keras and TensorFlow. As a conclusion, we can say that we able to differentiate non-memory memory recall from unknown memory recall based on the visual analysis, and we find that lowest objective levels of Bloom's taxonomy have different representation in the psychophysiological aspects. As a future work, we have to evaluate, we have to implement our machine learning model. So that's the end of our presentation. Thank you very much.
Okay, so I allow the audience to ask questions, please, from the presenter.
Thank you very much for the presentation. Again, I'm Janaka. Thank you very much for the presentation. It's really interesting. And one thing popped into my mind is that, yes, when we take the Bloom's taxonomy, yes, there are 7 levels, and you tested it for the first 2 levels, right?
Yeah, first two objective levels.
First 2 levels, yes. So then, like, even though that we get like remembering phase and the simple application in the second layer,
yeah,
there could be unlimited amount of possibilities of thinking patterns, right? Like the way that you think is not the way that I am thinking, but we are going to the same direction. The why we give the written exams and the remembering sort of recall exams in papers is like get those thinking into a one particular form, right? So how in this particular method, how you thought of, like, I know it is a very futuristic question, but how did you think that you will be getting all these like persons into a common understanding, because the different brain waves might differ depending on their psychological feelings as well.
Yeah, that's right. So basically, in the first we analyze in a graphical way. I think. Yeah. Then we use some ERP skull maps. ERP means event relational potentials. So we analyze those ERP skull maps and find that when there is a actual for if we show some phase basically, so there is some brain areas that work for when we see some phases, right? So basically, it's the backside of our brain. So then for if we when we engage in some some solving some mathematical equation, no, some if we doing some cognitive process, so in the for those kind of things, so basically in the brain area, so there the front area is getting a higher activation. Those are we saw in our experiment, and in in those our literature also we find that there is a known areas for these kind of works, right? So so in the analysis we basically saw that as a whole picture, but when then we implement our LSTM model, so it can there must be some so if we analyze in the ERP maps only, not the skull maps, so if we find that there is some kind of known pattern is visible on everyone's experiment. So we thought that so that can be identified by that can be learned by our LSTM model. So
and how many test subjects you used to came to like this ramification, like the conclusion?
So it's capturing age is if some days we were unable to capture the data from anyone. So it's a hard work. So we have to put that cap into our head. Then we have to do some changes for each one. So basically we come up to like this. We have about 50% were experimented. For this poster we use 17%.
17%.
Yeah.
Okay, and one last question, if I may. Like the Bloom's taxonomy is basically designed for the outcome-based education, right?
Yeah.
So, but the way that you all are like evaluating it is not sometimes the outcome-based education. It is what you all are like evaluating is the cognitive thinking of a particular person, right?
Yeah.
So how do you tally these two things?
So if I think that's a two different aspect. Like we based on basically if we based on the Bloom's taxonomy, we have those we have to there is some already those known facts about the Bloom's taxonomy. So we have to based on those things, right? So
there is a limitation if we deal with the Bloom's taxonomy, right? Like in the
that's some kind of taxonomy. So there is other aspects also. So it's we thought that this in the Bloom's taxonomy there is revised part. So in this our paper we use revised Bloom's taxonomy. So it has like it's basically categorize those knowledge levels also. It has a higher scope. So we thought that will be a good option.
But for the start, you thought of like using it with Bloom's taxonomy.
Yeah, Bloom's taxonomy. Then we find that we can go further in the revised Bloom's taxonomy.
Revised Bloom.
Yeah. So we move for revised Bloom's taxonomy. We have now the conceptual knowledge and the remembering, the factual and the remembering and the understanding, and factual and the conceptual. So we have 4 classes there. So that
Thank you very much. Yeah, it's very interesting. Thanks.
Okay.
Thank you, Janak, for that question, and also my question. Thank you, Madhuranga, for your work and the presentation as well. And my question is also related to like very much related to Janaka's question as to your how confident are you on the accuracy of your system?
I think those LSTM you mean that accuracy, the numbers, so the
No, I mean, okay, so like in the traditional test, like we can be confident, okay, this guy knows this, but how can are we like in the near future? Can he replace those tests with what you propose?
Yeah, I think the main burden we have was in those capturing equipment. So if we have some equipment like headset, we can put this one to our classes, and we can give some try. So if we wear like those like big caps, so basically it has some bias towards that thing. So basically we try to avoid that. We give them some time to relax and get familiar with our equipment. But in the practical scenario, there will be some biases, I think.
Okay, then thank you very much, Madhuranga and the team for your work and presentation as well. And I think we have to conclude this session for lunch. I thank all the presenters for their work and for coming here and presenting that work at this session. So let us all break for lunch and let's meet again at 2 for the keynote address. Thank you. Thank you, everybody.